I have for activity 5 summarizing questions. For the first part, to draw the give and receiver diagram, I put the dry cell battery was the energy giver, and it decreases in chemical potential energy and increases in thermal energy. And then through heat interaction, it goes to surroundings, and the surroundings increase in thermal energy. And then through electric circuit interaction, the energy is transferred to the fan, and the fan increases in kinetic energy and thermal energy. Um, from the fan, there's another heat interaction that goes to the surroundings, and the surroundings again increase in thermal energy. For the second part, I think it also said to create a conservative one of the I forgot. Oh, the conservation of energy. Sorry, correction, conservation of energy. So for that, I put the decrease in chemical energy. I forgot to put of the cell battery right here. Sorry, but of the cell battery equals an increase in kinetic energy of the fan, an increase in thermal energy of the fan, an increase in thermal energy of the dry cell battery, and an increase in thermal energy of the surroundings. So for number 2, I was a little confused on how to actually do the giver-receiver diagram for this part. So this is my attempt at it for when they're in equilibrium states. So the earlier one was for when they're, when they're in transient states. So this is for when they're in equilibrium states. I'm a little not super confident on this, but I tried my best. So I started with the dry cell battery, of course, and the decrease in chemical energy. And then through heat interaction, it does increase the thermal energy of the surroundings. I put through a contact push pull interaction, but I don't think that's right. I think it's a circuit interaction. Again, it's sent to the motor fan, but the motor fan and the dry cell battery, thermal wise, is at equilibrium. And the fan is at a constant speed, so there's no need to add any increase of any energy over here. But there is another energy interaction with the fan because the fan does heat up the surroundings. The surroundings again increase in thermal energy, so that's why I put. Because the motor fan is basically at equilibrium for the conservation equation. Sorry, I keep scrolling because I need to find the name. The conservation of energy thing, sorry, I put decrease in chemical energy of the dry cell battery equals an increase in thermal energy of the surroundings since the motor fan is at equilibrium. So that's again the answers to activity 5. The activity 5 summarizing questions.